Hello, this video is on section 6.1, which is titled Polygon Angle Sum Theorems. And there's two different targets. They're basically, the first one is to find the sum of the measures of the inside angles of the polygon. And the second one is to find the sum of the measures of the outside angles of a polygon. So let's go ahead and get started. The first theorem that I want to go through is, of course, corresponding to the first target, which is the sum of the measures of the interior angles of a polygon is equal to n minus 2 times 180. And n is represented to the number of sides. So you take the number of sides, you subtract 2, and you multiply it by 180. That number in degrees is equal to the sum of the measure of all of the angles inside of a polygon. So let's say, for example, we wanted to prove that a triangle is 180 degrees. A triangle is 3 sides. 3 minus 2 is 1 times 180, and that's equal to 180. So that's proof that there are 3 sides to a triangle and that all of the angles add up to equal 180 degrees. The next theorem is that the sum of the measure of the exterior angles of a polygon is 360. Every single time they're going to add up to 360 degrees. And what I mean by exterior angles, if let's say, for example, we have a pentagon, a five-sided shape. An exterior angle is something that if you extend the line out past the shape into the form of a vertex on all of the points. Okay, so this angle, this one, this one, this one, and that one, all of those are going to add up plus 2, plus angle 3, plus angle 4, plus angle 5, all add up to equal 360 degrees. And every single shape of a polygon, all of the exterior angles add up to equal 360. Now, sometimes they may be different, but they're all going to add up to equal 360. Okay, so a couple of examples. The sum of the interior angles of a heptagon. Well, first, a heptagon, how many sides is that? That is 7. I will put up a link in the locker that has a list of the names of polygons and the number of sides that it has. So you plug it into the formula, n minus 2 times 180. 7 minus 2 times 180. 7 minus 2 is 5. And you multiply that by 180. And you get 900 degrees. Okay? So another example problem may be if it was a regular heptagon to where all of the angles were equal to the same. What is the measure of one of the angles? And that's where you would take your 900 and divide it by 7, and that would get your answer. But the next example is dealing with exterior angles and finding the measure of this one right here, the measure of angle 1, which is an exterior angle. Since we know that they all add up to equal 360, and this is a regular octagon where all of the sides are the same, that means each of these angles on the outside are also the same. So we can take 360, which is the total, and divide it by the number of angles on the outside, which is 8. And if you take that number, 360, divided by 8, you will get 45 degrees. All right, so the biggest thing is the interior angles formula, and then just knowing that all of the exterior angles add up to equal 360, you should be good. We'll go more into detail in this chapter about polygons, but yeah, that's it.